Many times harmonic motion problems take the form of word problems. Here's an example. The string on a violin is pulled a distance of 0.5 centimeters above its rest position, then released and allowed to vibrate. The damping constant C for this string is determined to be 1.4. Suppose that the note produced is a pure G with a frequency of 200 Hz. Find an equation that describes the motion of the point at which the string was plucked. So this is a dampening motion problem. And since the string has been pulled from its rest position and then released, this has a starting point that's not at rest. So since it's not at rest, I'm probably going to use the cosine function instead of the sine. And for dampening, it's going to be y equals k e to the negative ct cosine omega t. So I now know the form of the equation I'm going to use, but I got to figure out what I need. Well, I can see right away that C is 1.4. So that's easy. Given to me, we just take it and move on. Now, I still need to find some other things in here. I can see that the violin string is pulled a distance of 0.5 centimeters above the rest position. That means it's as high as it goes and moves and is let go. So that is what K represents. So when we'll let K represent the amplitude, as it were, for this. So this is going to be 0.5 because that's its starting point. And then the last thing we know is that there's a frequency of 200 Hz because the note produced is what's considered a pure G. So it's a frequency of 200 Hz. So the frequency is 200. And we find the frequency by doing omega over 2 pi. And just solve for omega to get what we need in our equation. So multiply the 2 pi over, and we're going to get 400 pi equals omega. So we know C, K, and omega. That's all we need to write our equation, so plug it in. So y equals 0.5 e to the negative 1.4 t times cosine of 400 pi t. And so this whole equation here describes the motion for the string that was plucked on this violin.